Assalamualaikum warahmatullahi wabarakatuh. Dear everyone, okey, kalau masih ada yang belum join team ni, belum boleh masuk, tolong WhatsApp saya awak punya nombor student supaya saya boleh invite 169A169 394. A169A169 dah masuk tak? Dapat masuk tak? A169-394. Siapa nama ni? Tak bagi nama pula. A169-394. Okey. Saya share invite. Copy. Apa tu? Dia apa? A169. Kenapa dia kata we couldn't find any match? Anyway, okay. 170413. A170-568. A170-568. We couldn't find any match. Tak tahu kenapa. Okey, saya cuba share via default email dia kata. So awak awak cuba check awak punya email siapa yang tak boleh masuk tu. Ya. A170413. A170413. Dapat tak masuk? 413. 413. Maksudnya dah dapat dah ni. Okey, lagi siapa S6. Siapa ni? Dia WhatsApp saya nombor student, nombor matrik.
Hello Mr. Cat.
Ya.
Saya yang nombor matrik tadi A170568 tu.
Dah boleh
saya dapat join team sebab kawan yang call, tapi dalam MS Team saya tak ada appear group tu. So lain kali saya nak masuk, kawan kena call lagi.
Tak apa, you bagi saya nombor student. Mungkin sebab you dah dapat masuk walaupun guna kawan, jadi dia tak kata couldn't find. Tapi tak apalah, next lecture saya jangan request selalu kawan dulu. You tunggu saya key in you punya student number, ya. So nanti dia
tapi email saya tak dapat pun.
Oh, email pun tak ada. Tak apalah, next lecture you jangan masuk ikut kawan. You remind saya before lecture and send your student number, ya.
Okay.
Mungkin sebab you dah masuk ni, jadi dia kata tak boleh find, couldn't find dia. Because you dah dapat masuk. Tapi tak apa, next lecture you jangan masuk ikut kawan. You tunggu saya key in you punya nombor matrik,
Mr. Cat boleh Mr. Cat boleh terus bagi MS Team punya code untuk access, so orang tu boleh terus guna code untuk masuk MS Team tu.
Ya, saya pun tak tahu macam nak bagi you code tu. Tak apalah, sebab saya nak cari kod tu mungkin makan masa. Kita cuba cara tu dululah, Saya tak tahu kat mana nak cari kod tu, nanti takes time pula, dia lecture saya ke delay pula.
Okay. Thank you Mr. Cat.
Alright. Saya masih lagi ada yang hantar nombor student ni, so saya tunggu sekejap. Saya tengah key in nombor student yang belum dapat join ni, sekejap Okey. Ini A170603 ni pun sama saya rasa, dia dapat masuk tak? A170. Okay, just to remind you, those who masuk ikut kawan, those who join my team by click from your friend, please next time you do not do that. Before the lecture start, you WhatsApp me your student number, because once you enter through your friend, I search your student number, the system say couldn't find because you already inside the system. So next time you don't log in through your phone, through your friend, but you WhatsApp me your student number. so that I request, invite you to join. Remember, everybody, because after you join using your friend ID, and then I search your ID, so metric number, they said couldn't find any match. Okay, understand? Okay, so I'm going to start now. Okay, because I received WhatsApp of some of your friends, some of you, your student number, but when I search, it says couldn't find. That means you might have joined, but using your friend's link or something like that. Okay, so I think I'm going to begin my lecture now. Okay, let's see. Okay, so last lecture I was trying to retrieve this file but couldn't make it, and today I'm going to talk about this particular topic, which is on the parachute stuff. So this is the diagram of the parachutist. All the forces acting on the parachutist is shown in the diagram. Fu due to air resistance, force, upward force due to air resistance, and Fd is the force due to gravity. So this is the velocity of the parachutist at any time t. Okay. Okay. Now, the very first method that I'm going to teach you today is on the graphical method of numerical computation.
Mr. Cat, share screen. Mr. Cat, share screen tak?
Dah share dah, tak nampak
Tak nampak Mr. Cat.
Orang lain nampak tak? Orang lain?
Saya punya ada.
Nampak.
Ada.
Orang lain nampak, so macam mana nak sebut ada lagi selain daripada awak yang tak nampak tak, orang lain? Mungkin awak ada problem.
Saya tak nampak.
Nampak kan?
Tak nampak.
Saya pun tak nampak.
Oh ya, sekejap. Sekejap komputer saya buffering sekejap Okey, sekarang nampak tak? Nampak tak?
Nampak.
Nampak dah Mr. Cat.
Tak dengar? Okey tak? Tak nampak
Okey
lagi?
Mr. Cat. Okey
Nampak
Mr.
Mr. Cat, nampak.
Okay. So this is the first method that I'm going to teach you on numerical calculation. Okay. Now we have this formula: velocity equal gm/c times 1 minus exponential minus c/m multiplied by t. These are the parameter defined here. G, what is G? M, G is the gravitational constant, M is the mass of the parachutist, C is the drag coefficient of the air, and T is time in second. Okay, this is the question. A parachutist of mass 68.1 kg jumps out of a stationary hot air balloon. Okay, use equation 1, this particular equation. Okay, to compute velocity prior to opening the chute. The drag coefficient is equals to 12.5 kilogram per second. Okay, so what is the velocity before the chute open? That's what the question is asking. Okay, so we substitute the given parameters like the mass, the gravitational acceleration, which is 9.81, and also the drag coefficient C. Okay, so we're going to supply the value of G, M, C. Okay, so the only unknown is T now, right? Okay, you see here all the numbers has been substituted except the T and of course the dependent variable V. Okay, so of course time will always start from 0, cannot be negative lah. Okay, so the time 0 means the parachutist is just about to jump from the airplane. Okay. Okay, now we can plot the V or T versus V. Okay, so T is the independent variable, V is the dependent variable. So T start from 0, so you use your calculator. You press the value. You look for the value using your calculator. You get your V 0. When time 0, velocity 0. So you increase the time with an interval of, let's say, 2 seconds, 4, 6, 8, 12, 10, 12 until infinity. Okay, and at the same time you calculate the velocity V using your calculator. So this is the value you got. See, the value of the velocity starts to increase. As time increase, the value increase. Okay. Now, when T become infinity, that means T become infinity. So minus means 1 over, right? 1 over. So 1 over exponential 0 positive, because if you change the negative to 1 over, become 1 over exponential positive 0.18355 T. So as T approaches infinity, exponential to the power of infinity will be infinity. So 1 over infinity will be 0. Okay, so V will be 53.44 multiplied by 1 minus 0, which is 53.44. This one is 47.54. Okay, understand? Okay. According to the model, the velocity model, model here means equation, okay, the velocity equation 1. The parachutist accelerates rapidly, okay. So a velocity of 44.92 meter per second is attained after 10 seconds. Note also that after a sufficiently long time, a constant velocity, which we call terminal velocity, of 53.44 meter per second is reached. That means when time goes to infinity, okay, the velocity doesn't change. Okay, the velocity is constant at 53.44 meter per second. Will not be increased anymore. Okay. So the velocity is constant because eventually the force of gravity will be balanced with the air resistance. Thus, the net force is 0 and acceleration has stopped, ceased. Okay? That means when velocity is 0, acceleration of course 0. So if you plot V versus T, okay, this is the graph that you will get. Okay? See there? So the peak here is called the terminal velocity. So it will be flat. Top here it will be just flat like that. Okay. All right. Okay. So what is the answer to the question then? Okay. The answer to the question. Okay. The drag. Okay, use equation 1 to calculate velocity prior to opening the chute. That means the velocity is 53.44 lah. Okay, so that is the highest velocity that the parachute attain at a constant velocity of 53.44, and then he opens up the chute. Okay, the so-called umbrella that stopped him from, that made him slower, right? Okay. So the answer for this question is 53.44. You have to write the answer, okay? Because some students, a lot of students, they just calculate like that, and then I don't know what is the answer. Okay, of course the calculation is correct, but what is the final answer? It's a number, see? So you have to say then you can say that the velocity is for 53.44. Not only for this problem, all other problem that I'm going to teach you, same thing, you know. Student keep doing the iteration, but then he just left the question like that. So you have to give the final answer, okay? Because the final answer might contribute to 2 points or maybe 1 point or 3 points maybe. So if you do not give the final answer, then you will miss the point, okay, the marks. Now this particular equation 1, the velocity equation, is called analytical or exact, okay, solution, because it exactly satisfies the original differential equation. Okay, that means this particular, originally what is the equation looks like? dv over dt is equivalent to, remember last lecture, it starts from a differential equation, right? dv over dt equal some parameter f in terms of t, g, and so on, and then we apply analytical method which you learn in differential equation. You get this answer. This answer for V, so this we call the solution for V equal is called analytical method. Okay, that means analytical means exact method. Okay, so called exact we call it exact method so analytical. Okay, now so solving equation 1 and shown above is called the analytical solution to the differential equation, because it exactly satisfies the original differential equation. Unfortunately, there are many mathematical models. That means mathematical models here, let's say we have example like dv over dt equal m square times sine bracket ln of exponential or minus y square g or something like that. So these are the type of question that categorized as cannot be solved exactly, okay, because it's complicated. And in fact, almost 90%, more than 90% of engineering problem, you can't solve it using exact method. Or you can, or analytical method, same analytical. You cannot solve it like x square equals 4, x equal plus or minus square root of 2, for example. That is analytical solution. But most engineering problem, you can't do that. You can't solve it using analytical method. Therefore, this is the reason that we need a numerical method. In many of these cases, that means in many of mathematical model, the only alternative is to develop numerical solution that approximates the exact solution. Okay. Okay. As mentioned previously, numerical methods are those which the mathematical problem is reformulated so that it can solve by arithmetic operation. This can be illustrated by applying Newton's second law, okay, realizing that the time rate of change of velocity can be approximated by figure 1 for 1.4, okay, this is the figure, okay, here. So this is a graph of V versus T, okay, and then dV over dt, which is the slope, which is the equation of the differential equation, or in other words, the mathematical model that we are talking about here, okay, can be approximated by applying the slope equation, okay, delta V over delta T, because dV over dt is approximately equivalent to delta V over delta T, which delta V over delta T is the change in velocity Vti plus 1 minus Vti, which is this one, okay, this line, delta V, okay, divided by the change of time Ti plus 1 minus Ti, this one, okay, so this is approximate already. So dV over dt, okay, it can be approximated by applying delta V over delta T, okay. So when we talk about approximation, then that comes the numerical method, okay. See that dV over dt is approximately equivalent to delta V over delta T, okay. Okay, delta V and delta T are the change in velocity and time, okay, and so on. So if you still remember calculus, to get delta V, dV over dt, we take the limit of delta V over delta T as delta T approaches 0, okay. So if you apply the differential equation involving the velocity of the parachute guy just now, so you can write delta V over delta T approximately equivalent to Vti plus 1 minus Vti over Ti plus 1 minus Ti. So this is delta V of dV over dt lah. But it's already being approximated by using delta V over delta T. Yeah? Delta means the symbol Greek letter, triangle letter, yeah, delta. Okay. Okay. So dV, this is the original equation that I mentioned in the previous lecture. Remember, dV over dt equal G minus C over M times Vti, and then you solve using one of the technique in calculus that you have learned, differential equation actually. One of the technique that being taught in differential equation for first order differential equation, for example, linear method or separation of variable or exact method, remember? So you got the dV over V equation as solving by analytical method here. Okay, this is analytical method. Okay. All right. Now, so now this particular article or this particular topic here now, this particular sentence is teaching you how to solve or use the equation by using numerical method and applying Newton or differential equation of principle of limit to solve differential equation. Okay, so the concept of this equation, okay, which is a numerical equation, numerical, not analytical, numerical. So the new value of V, see that? The new Vti plus 1, that means T in the future, something to come coming to you. Vti plus 1 is Vti, the current Vt, the current velocity, plus, okay, the quantity here times Ti plus 1 minus Ti is from here. You get it by solving Vti algebraically, yeah? Using algebra. I'm sure you can do that. You bring this to the right, and then minus bring to the right become positive. Okay. Okay. Now we are going this particular approach that we apply for the differential equation to get the numerical equation is by applying Euler method. Okay. Anyway, this Euler method will be deal again later in the chapter, but here only demonstrate a simple form for you to get some understanding on the different applying new analytical solution and numerical solution. Okay. So look at this numerical equation on this example here. See this example. Perform the same computation as the previous example, but now using equation 112, this one. Okay, to calculate the velocity, employ a step size of 2 seconds for the calculation. Okay, so here you need to decide on the step size for you to get the next velocity compared to the current velocity. So the step size is up to you to decide. The smaller the step size, okay, the more accurate the value you will get. Okay, but the calculation involve more steps. If you use a bigger step size, like instead of 2 seconds, you use 4 seconds, then your calculation will be shorter, but the result will not be that precise, not accurate. Okay, all right. Okay, let's start to calculate the velocity using numerical equation here and see what the result we get. Okay. Now we start with Ti equals 0. So we need to plot like that. Okay. So the first column, okay, the first column we input the time based on our decided step size. So compared to the previous example, this is an analytical solution. I hope you still remember. Although the numbers are the same, it's just coincident that we get the same number. Actually, it doesn't have to be the same. Okay, between analytical and numerical method. So it just so happened that in this numerical calculation, they choose 2 second interval, 0 to 4. So this one doesn't have to follow the step size of the numerical equation. You can start with 0, 4, 8, 12, and then 16, and so on. Yeah? Okay. But they just happen that maybe they want to compare the numbers. Okay, between numerical and analytical. So you see the numbers here, 0, 19.62, 32.04. See, the number will not be the same, you see, because, but it will be close. It will be close. Of course, this is more accurate because it's analytical, whereas this is numerical. So the numerical will have some error, definitely. Okay. All right. So after we decide the step size to be 2 seconds, okay, then we can fill up this first column. This first column first. So we start with 0, 2, 4, 6, 8, 12, 10, 12, 14, 18, add more, you can add more, 12, 8, 16, 18, 20, add more. Okay, so once you fill up the first column, okay, then you can begin calculate the corresponding value of V. Okay, all right. So when T equals, of course, you know that the initial value is when time 0, velocity is definitely 0. Okay, so you know that. So this one you can fill up because that one you will need to decide by looking at the situation of the problem. Okay, you should know in physics also you have done this several times already. Okay, at the moment the person is about to jump, the velocity will be zero. Not like shooting a cannon, for example, right? If you cannonball at time zero, the velocity is not zero, right? Because when the time zero, it starts to shoot the ball, so the cannonball. So you have some velocity non-zero here, right? But for a parachute, you should know that from when t equals 0, b equals 0. Okay. But in this analytical equation, you won't be able to calculate it directly when t equals 0, b. But here you can. On the analytical equation, you can substitute t equals 0, you get b equals 0 here. But in this mathematical equation, cannot. So you need to make the judgment yourself. Okay. The first answer you have to look at the case by case basis. Okay. Next, at the start of the computation, t equals 0, the velocity is 0. Using this information and the parameter value from example 1.1, equation 112. The parameter value means the g, the mass of a person, the c is the drag coefficient. That one follow the same to substitute here. That's what it means. Not to copy the velocity. No, not the velocity. This one you have to calculate differently. Only g, c, and m that you take from the previous value. Okay, so what we have here now, the new v, when time equals 2 seconds, okay, that means v bracket 2 equal v0. Ti means t0, the previous one, plus g minus c over m, v0. Okay, ti plus 1 means 2 minus 0. Understand? So that's what they got here. So you get 19.62. Put it here. Okay. Okay. Next. Okay. V4. V bracket 4 because the next one is 4 seconds here. Okay. So V4 equal V bracket 2. Okay. Plus in the multiply quantity of g minus c over m, v2, close parenthesis, close bracket, times 4 minus 2. Understand? But they don't show it here anymore. This one is for the previous answer. Okay. They show you, sorry. They show you here from t equals 2 to 4 seconds. So they give you the calculation here. But after that, from 4 to 6 and 6 to 8, 8 to 10, 10 to 12, they don't show you anymore. So make sure you know how to substitute the correct number. That means V10, for example, V in the bracket 10 equal V in the bracket 8. So V in the bracket 8, you already know from the previous calculation. So V8 plus parenthesis G minus C over M is known parameter. Substitute it. And then V8. Okay, times 10 minus 8. Understand? So you get 48.02. And notice, after, let's say, if you look at the analytical solution, analytical solution, okay, they stop at 12. But it doesn't mean at 14, is 47.54 or 53.44? No, right? Because when time equals 14, there is still some value between 47.54 and 53.54, right? There's some value here. Okay, now for this mathematical solution, we call this more numerical equation. Okay, if you try to calculate at t equal 14, then you will get some value between 50.01 to 53.44. Okay? Okay. Now, once you substitute infinity inside this equation, when t equivalents to infinity, so you will get the answer to be 53.44. Okay, and when t equivalent, so of course this t equal infinity, it will be the same as this one. It will be the same as this. Okay, because infinity it can be a numerical method or analytical method. When you got a negative, the infinity value, it will be the same answer. So that's why they will put it here 53.44 straight away. But from this equation, you can't let t to be infinity here, because otherwise it will be infinity minus infinity. Then you have indeterminate equation. That's another topic that you have to remember. I don't know whether you came across with that in your calculus. Infinity minus infinity is called indeterminate form. So the last equation, they just get it from the analytical method. Okay. The result are plotted in the figure 1.5 along with the exact solution. Okay, now they plot it on the same graph. Okay, figure 1.5. Here. So you can see from this figure, the value doesn't match exactly between analytical and numerical. There will be some error there, correct? But eventually, as it goes to infinity, the line will overlap. That means it will be superimposed on one another. Okay, so this is the bottom one is the exact solution, whereas the top one is the approximate numerical solution. Okay. Okay, this is quite interesting and also important statement here. As I mentioned just now, also I also did mention in my previous, earlier in this lecture. It says here, one way to minimize the discrepancy, which is the error. This is actually the error. From here to here is called the error. All right. So to close this gap, this error, okay, what you can do is you use a smaller step size. Okay. So instead of 0 to 2, you just add 0 to 1, 1 to 2, 2 to 3. So your answer will be closer to the exact solution. The graph will be closer, but you need more step, okay, more row in your table. Okay, will be computational will be longer. Okay. For example, apply equation 112 at 1 second interval, result a smaller error as the straight line segment track closer to the true solution. Okay. So that is the content of this. I already emailed to you this particular PowerPoint. Okay, let me go into the next topic. With the time remaining, I have about 10 minutes that I have. I'm going to proceed. You wait for a while for me to load the PowerPoint or the PDF. Okay. Okay, very good attendance today. Very good. Okay, let me show you the next. Okay, I hope you can see it in your computer. This by PDF file. Okay, the next method that I'm going to talk to you is on what we call bracketing method. Bracketing. The word bracket means you track the what we call the solution. Okay, at the very beginning, you already like you go for fishing, so you set a trap. So that the fish is within your trap. So the word bracketing has the same concept like that. You bracket first, and then you reduce the bracket, make it smaller, smaller, smaller. Like you pull out the net of your fishing that you throw it to the water, the net, and then you pull it, and the net will be getting shrinking and shrinking, and finally caught the fish. So that's the concept is like that. You bracket first the solution, and then you keep reducing the bracket until you get the answer. Understand? Okay. In this topic, the first method that covers is called the graphical method. Okay, so the graphical method is slightly what we call similar to the one that I just talked about just now, where you need to plot a graph. Okay, in all these chapter 5, in fact 5, 6, 7 like that, on solving for solution of the numerical method, you need to find the root. Okay, you need to find the root of the equation. Okay, so we start with graphical method. A simple method for obtaining and estimate the root of equation fx equivalence to 0 is to make a plot of the function. Okay, so I'm sure you have came across with this method whereby you sketch the graph. Okay, all right. So that is sketching the graph is called the graphical method. In order to find the root of the equation fx equals 0. Okay. However, you might also be aware that this method is just approximate method, because you cannot read exactly the very good answer by your eyeball. I mean by visual inspection or reading of the graph, you cannot get a very, very accurate answer. Okay. But again, this first method, or we say second method, the first method is to teach you how to plot the graph just now. So this second method, which is the graphical method, is still considered to be numerical method. Okay. Now, this particular method is a problem that seek the root of x for an equation fx equivalence to 0. Look at this example. Use graphical method to determine the drag coefficient C needed for a parachutist of mass 68.1 kilogram to have a velocity of 40 meter per second after free falling for time t equal 10 seconds. Okay? Alright. So this question is little bit from a different angle, okay, but utilizing the same equation of the parachutist. Just now, if you remember, the value of drag coefficient is already given to you, okay, based on the air resistance, okay. The parachutist with a mass of 61.8 kilogram will attain a velocity of 40 meter per second at the time of t equal 10 seconds. Okay? So, what is C? Now, the acceleration due to gravity is given to be 9.81 meter per second square. Okay? Now, since C is the parameter that we are looking for, therefore, we write the function f in terms of C. Okay? Alright. Now, can you rewrite the previous equation in terms of C? So it's very simple, right? What you do is you just FC equivalents to 0. Okay? So you just bring the velocity to the right. Okay? There's no V, and V equivalents to something, right? Remember? Solving the differential equation dV over dt equal, you get V equal something. So now what we can do is we bring V to the right, and the whole equation on the right set it equivalents to 0. That means the V, once you bring it to the right, the left hand side becomes 0. Correct? So you flip the equation such that the equivalence to 0 will be on the right hand side, like that. Just flip the equation. So if you flip the equation will be still the same. Okay? You don't negative or positive the term anymore because you only flip the equation. So the equation will still be the same, but it will be in this form: Fc equals 0. In other words, G times M, or mg over C multiplied by 1 minus E to the power of minus E to the power of negative C over M bracket 10, which is the time T. Okay, minus V equals 0. Okay, so that's as simple as that, to write a form in terms of FC. So FC equal this, which is equivalent to 0 lah. Okay. Now, substitute the given value of the velocity, which is 40 meter per second, time 10 seconds, mass of the parachutist 68.1, and C is the unknown, right? So various value of C can be substituted into the right hand side of this equation to compute. Okay, so you just start to, if you set C equivalent to 0, what happen? Cannot, because you cannot divide a number with a 0. So you start with a non-zero. Here, it so happen you choose 4. You can start with 2 or 1, and then you increase the drag coefficient. Okay. So you notice the corresponding value of the function, okay, will be positive, and then somewhere here will change to negative. Okay, right? So how to find the value of f Okay, or in other words, the value of C is such that FC equals 0. This one equals 0. All this equation is actually equivalent to 0, right? So can you, by applying this C value, the FC, we need it somewhere here, right? 0 is somewhere here. So these points are plotted in figure 5.1. This is the figure. The resulting curve cross yeah. So this is the figure. So you plot F versus C, FC versus C. So this is the value from positive to negative. So the moment FC equals 0, that means that is where the C value is desired. The desired C value that we are looking for. So that is the root of the equation. Okay, we call it the root of the equation. The root means when the function equals 0, right? Remember? Okay, so you read it from the graph as exactly as possible. If you use fine graph paper, I mean the box is smaller, and you use a scale which is 1 centimeter equivalent to 10 or 5 drag coefficient, then you might not be as accurate as someone who choose 1 centimeter to 20, for example, right? To 2 drag coefficient value of 2, 2, 4, 6, 8, 10. Okay, so it doesn't matter because all this graphical method is actually just an approximate method. So by reading from the graph where FC equals 0, you get the root, we call it, and this is called graphical method of finding the root. Okay, so what was this? Okay, so by reading the graph paper, we can get an approximate root of 14.75 from here. You can read it from 14.75, and then if you substitute back the value, it will be equivalent to 0.05, which is almost equivalent to 0. We need it to be equivalent to 0, right? Okay, so this is already almost equivalent to 0. So, and then you can also reverse your check by substitute the time and also the mass G and what we call time, mass, and G inside the V equation and got it close to 40. Okay, correct? Because the equation 1, the drag coefficient when the velocity is 40. So this is just a double check. Okay, close to 40. So okay. So this is called graphical method. So that's it. I promise you to stop because early due to you have. So next week, remember our time. Look at the WhatsApp that I sent to you. Okay. So any question? Now today attendance is full. I would say full. So I will mark the attendance as everyone came today. But let me see. But I also can download it, I think. So I will also download the attendance. Okay. All right. Any question? So if you don't have question, then we'll see you next week. Okay. The time. Look at my message. Okay. Any question? No question. Very good. Keep it up with your attendance. Okay? Everybody?
Okay, Mr. Cat.
Alright. See you.
Thank you, Mr. Cat.
Have a nice day. Enjoy your next lecture.
Thank you, Mr. Cat.
Okay.
Thank you,
Bye.
Thank you, Mr. Cat.
Assalamualaikum.
Thank you, Mr. Cat.
Mr. Cat.
Bye-bye.
Thank you, Mr. Cat.
Thanks, Cat. Thank you, Mr. Cat.
Thank you, Mr. Cat.